All right, guys, thought I'd shape or change things up a little bit and use a different type of PowerPoint, if nothing else, to keep me from going insane here. This is on sampling distributions, except, we think about central limit theorem, except for means for proportions. Now, this particular concept will drive your students insane because there's some crazy stuff going on here. First of all, sampling distributions for proportions deals with categorical data. But your students are going to want to think it's quantitative data because we express the categorical data as percentages. So you think about gender. You walk into a classroom and you got 5 students, 2 female, 3 male. Well, you've counted, right? And gender is clearly categorical. But when you summarize that data, you would say that you had two females, which is 40%, and 3 females, or 3 males, I'm sorry, out of the 5, which would be 60%. Well, the 40% and 60% are clearly numbers, but they are expressing measurements from a variable that is clearly categorical. So, man, I tell you what, good luck explaining that one to your students. It's one of those concepts and one of those things that you just got to keep on every single day. That when we deal with sampling distributions and central limit theorem for proportions, that we're talking about categorical data. All right, so previously we've looked at the distribution of sample means x bar, and the central limit theorem at the end of the day tells us that if we have a normal distribution, or if n is large, then our distribution of sample means will be normally distributed, have a mean mu sub x bar of mu, and have a standard error of sigma divided by the square root of n. Means are quantitative. So what happens when we have categorical data? Well, I'll tell you what happens. The notation gets insane for students, and it's a tougher concept. So we have a new notation. Instead of mu being a population mean, we have a population proportion, which can be thought of as a percentage that we'll call P, and the sample proportion is going to be P hat. Now guys, you got to remember the sample proportion, P hat, is thought of as a count out of the whole. So this, let me get my pen going here. So the count X, remember the gender example I gave you where we had 2 out of 5, which we all know is 0.40. Or 40%. And making this very subtle connection that X is the count out of the whole is a tough one for students. Guys, I fight it every single semester. So why are percentages categorical? Let's look at an example. Studies show that 32% of Facebook users update their status at least once a day. A random sample of 1,000 Facebook users is collected, and 325 report that they update their status at least once per day. So why is this categorical? Well, pretty simple. The user either does or does not update their Facebook status daily. What's the value of P? That's 32% or 0.32. And what's the value of P hat? Well, that's the count, 325, out of the total, which is 1,000, or 0.325. Central limit theorem for proportions. Central limit theorem tells us that if np and n times 1 minus p are both larger than 10, then our distribution of sample proportions will be normally distributed. Have a mean, not mu sub x bar, but mu sub p hat, equal p, and the standard error will be given as p times 1 minus p over n raised to the 1/2 power as the square root of that. Now guys, I'm telling you, your students will struggle with this notation. So you have to spend a little bit extra time on these types of problems. I've given you a note at the bottom. Some of the textbooks, including the one that we use at Shawnee State, uses Q instead of 1 minus P. So students are all the time saying, well, I didn't know how to do the homework because I didn't understand what the Q was. I'm not sure I believe them, but anyway, I guess I should have been more thorough. All right, gang, let's work a problem. Previous results indicate that 32% of Facebook users update their status at least 1 time per day. So our population is known. Therefore, we can calculate a probability. So a random sample of 1,000 Facebook users, select what's the probability that 325 or more update their status at least 1 time per day. So guys, trying to find probability, so we're thinking normal CDF. But before we get crazy, let's check our conditions. We need n times p to be bigger than 10, that's 320. And we need n times 1 minus p, or n times q, to be bigger than 10, so both are clearly bigger than 10. So we have a solid model. Central limit theorem tells us because n times p and n times 1 minus p are both bigger than 10, shape is normal. The mean is going to be 0.32 because 32% of all Facebook users say they update their status once, at least once a day. And the standard error will be 0.0148. Guys, grab your calculator. Use the normal CDF key just as before. If you look back at the problem, we want more than 325 out of 1,000. So my lower bound would be 0.325, or 325 divided by 1,000. Upper bound, clearly infinity. And my mean and my standard deviation as I've provided it. Guys, this is going to be a short video. If you press enter, you can see that the probability is 0.3673, and the student will successfully have worked the problem. All right, gang, short video here. There will be other things that you'll need to do in the distribution of sample proportions, but you know, a lot of those are covered in the videos that the students will watch as well. But in terms of teaching, if you can get the foundation, check the assumptions, understand what the center, shape, and spread, I think you're in an adequate position to teach your students some really cool stuff.